Hardness. Can you guys tell me about the hardness of metals?
It is really hard.
Most are very hard.
Except lead. Lead can't be beaten into sheets or anything, right?
Okay.
Gold is malleable, so it's not exactly. It's ductile and yeah, it's pretty ductile, so it's not as hard as other metals.
Okay. So somebody mentioned ductile. What is the meaning of ductile?
I always get confused in ductile or malleable. I guess ductile is it can be beaten into thin sheets.
Okay, actually that is malleable. Now tell me what ductile is.
It can be drawn into thin wires.
Very good, yes. Okay, so remember, if you want to remember this, just the words that you used, you draw something, it is ductile. Okay, so drawing into wires, ductile. Okay. Yeah, and malleable is basically, you know, when you talk about that hammer, right? You take a hammer and you draw it. You draw metal in sheets.
Ma'am,
yes.
copper, one like something that's very ductile. For example, an example could be copper.
Yes, copper wires are very extensively used.
And also, ma'am, malleable, I think it's iron.
Okay.
Iron is both.
Iron
is.
But it is really hard to do it. You need huge machines to do it.
Yeah, there are more malleable substances than iron.
Iron is ductile, but it's really hard to like bend it and stuff. And also,
correct.
It can be bent really easily, right?
Iron isn't bent very easily.
No, iron is not bent very easily.
No, unlike copper. Copper is actually bent very easily.
So copper, you can like literally bend it like this, but if you pick out an iron nail, are you able to do that with an iron nail?
No.
No. So, but you'll be able to do that with copper, gold, etc. Okay, so now, so we know metals are really, really hard. So what is an exception to that property?
Sodium.
Okay, very good. What else?
Potassium.
What is
and sodium and potassium can be cut with knife.
Okay, very good. Yes. So those are actually very soft metals. Sodium and potassium are really, really soft metals. And yeah, they can be cut with knife. So obviously we know that not all metals are equally hard. They can easily be cut with knife, sodium and potassium. All right. What is tensile strength? Okay, this is really important, guys. You need to know what tensile strength is. You're going to have it pretty much for all of your classes for the rest of your life. So, what is tensile strength? Okay, so the ability to hold large weight without breaking. Okay, so can you give me an example of a metal which has a high tensile strength? Metal iron or alloy? Yes, iron. Yes.
Steel.
Steel. Very good. Okay.
Aluminium? No. Aluminium ripped? No.
No, not really. I would not say aluminum has a high tensile strength. Okay. So yeah, iron and steel. These are, you know, examples of a metal and an alloy which have really high tensile strength. So now, can you tell me? Yes, Kirtana? What is it?
Even tungsten has a high tensile strength.
Does tungsten have a high tensile strength?
I was going to say that.
It has a higher tensile
it does.
strength.
Where is it used?
Airplanes. Yeah, airplanes hold so much of pressure when they're in air, so it is tensile, right? They use tungsten in the body, the airplane's body.
So I know. Yeah, tell me.
Airplanes use tungsten on their outer body, right? So it holds so much of pressure when it's in air. So it might have a high tensile strength.
It's known to have the highest.
Yeah, it has. Its tensile strength is actually 10 times higher than iron. Okay. I'm not sure if it's iron or steel. Maybe steel. Hold on. Let me check. Oh yeah. So yeah, it is 10 times higher than steel. And steel, we make steel bridges, steel, structures, buildings, and tungsten is.
Then why don't you use tungsten instead of steel?
Very good. Can somebody tell me why?
Man, this tungsten is harder.
It reacts.
It doesn't. Why is it used in electric bulbs?
I'm afraid of.
Is it expensive or it is really hard to find?
So tungsten has a very high melting point.
Melting point.
Oh. Yes.
Oh.
Oh yeah, tennis rackets are made out of tungsten. Some of them
Yes.
are.
Yes.
I have a tennis racket.
So because it has a high melting point, that is the reason why it's hard to shape them in the way we want it. And like tungsten is like somewhere about 3000 degrees Celsius, and we saw that iron is somewhere about 1500. So that's pretty much like half the temperature in which you can shape iron and use it in whatever way you want to. But with tungsten, it's much harder to do that. Okay. All right. So the exception to that is sodium and potassium. They are not strong. They have low tensile strength, obviously, because they are also soft. They're pretty easy to mend. All right. So what?
Is chalk a metal?
Is chalk a metal? You tell me.
I think it's not, but I'm not sure.
Okay. Can you tell me the chemical formula for chalk?
I don't remember. I'm not really good with.
Very good. Calcium carbonate. Okay. So how do I write it chemically? How will I write calcium carbonate?
CO3.
Ma'am, CO3.
Okay. So is that a metal?
Ma'am, it isn't a metal.
Okay. Good.
Oh.
All right. All right. So